And now a look to the skies and some of the objects in our solar system. A paper published last week in the journal Geophysical Research Letters outlines why cold, distant Pluto is still very likely to have a liquid ocean buried deep beneath its icy surface. Well, how can this be? It turns out that the planet shows signs of recent expansion. Expansion is seen in images from New Horizon, the spacecraft that flew by, and this research calculates that the most likely explanation is the slow conversion of liquid water to ice, which takes up more space. You know, water expands when it freezes. So to make that happen, of course, you need that liquid water, possibly as deep as 50 kilometers. Here to tell this story are the two co-authors on that research paper. Noah Hammond, a graduate student in the Department of Earth, Environmental, and Planetary Science at Brown University. Amy Barr-Milinar is a senior scientist at Planetary Science Institute. Welcome to Science Friday.
Great to be here. Thank you.
Let's talk about, Noah, walk us through your finding. How do we know there's an ocean on Pluto?
Well, it's really extraordinary. New Horizons flew past Pluto last year and saw images on the surface of these cracks, long tectonic cracks, which were interpreted as extensional tectonic features. And as you said, when an ocean is slowly freezing, that can cause Pluto to get bigger. Pluto expands. So what we did was we ran some calculations called, thermal evolution models. Basically, we started with Pluto soon after it formed, and we determined how quickly is it going to lose its heat over geologic time. And we determined that Pluto probably still has an ocean today if those extensional features on the surface are present.
Wow. Mm-hmm. Pluto is far from the sun, doesn't seem to have any major tidal forces acting on it. So what kind of energy is keeping that water liquid underneath there?
Well, what it has is these, we think Pluto is made up of an ice shell on the surface, probably about 150 kilometers thick, and then an ocean. Then it has this rocky core.
Right.
And in that core are these heat-producing elements. We actually have the same heat-producing elements in the Earth's crust, like uranium, potassium. These just give off heat as they decay over time. And that little bit amount of energy is enough to keep an ocean sustained on Pluto.
Dr. Molina, one of the factors that the model relies on is a substance called ice-2. Sounds like a movie. What's going on with that?
Well, there are actually several different phases of water ice. The phase of ice that we're familiar with in our everyday life is called ice 1, and that's the phase of ice that floats on water. But then as ice is compressed, like at high pressures inside Pluto's interior, the crystal structure actually changes and it becomes denser. So if you compress ice under very cold conditions, you get this phase of ice called ice 2. And so when you compress the ice like this, Pluto can undergo net contraction. And when that ice melts, then Pluto undergoes net expansion.
And Noah Hammond, what has New Horizons contributed to our understanding of Pluto and Pluto's composition? It has really sent back a lot of data, hasn't it?
Oh, it sure has. It's seen a number of really extraordinary things on the surface. There are these nitrogen ices, which appear to be convecting and refreshing the surface, making it look very geologically young. And I think what we really focused on was the extensional tectonic features, because it's really great that we can look at what's on the surface to infer what's on the inside. And if Pluto has an ocean, that has really profound implications for astrobiology and the rest of the solar system if liquid water can exist in such a cold, dark place.
Well, I hear you hinting about life here. When you say
I don't want to get carried away.
I want to make sure we're on the record about what you're talking about. So you're not when you say astrobiology, what do you mean by that?
Well, we know that liquid water on Earth is essential for life. So when anytime you discover liquid water planet or dwarf planet or moon, it gets astrobiologists excited.
So take us beyond Pluto, because Pluto has now been classified as a dwarf planet by some, and there are other, as you say, other dwarf planets out there. Take us beyond Pluto. Do they have findings, have indications or implications for the rest of our solar system?
Amy, do you want to take that?
Yeah, I mean, I think one of the things that's really amazing about this result is that it looks like Pluto, like a lot of other icy bodies in our solar system, have an ocean, and it certainly wasn't expected when we, went out to Jupiter's moons with the Galileo mission, or to the moons of Saturn with Cassini, or to Pluto with New Horizons. We didn't expect to find oceans in any of these icy bodies, and now it looks like that's a really common feature for icy bodies. Both moons of the outer planets and Kuiper Belt objects as well. And so, what's really interesting to me is the possibility that perhaps maybe other Kuiper Belt objects might have moons, maybe, oceans. Oceans appear to be common features in the outer solar system, and that's really surprising. That's definitely not something that we expected.
I'm Ira Flato. This is Science Friday from PRI, Public Radio International. I spoke to Alan Stern, one of your compatriots, on the New Horizons project early this week, and he said it seems like we are Earth is the outlier. We have the external ocean. Everybody else has an internal ocean.
That's true.
That is absolutely amazing, don't you think? Well, let's talk about what the next questions to tackle about Pluto and the body's like. What else do you want to know, Noah? What's there to learn?
Well, I think it would be really great if we could, understand how thick the ocean is and what its chemical composition is. Obviously, that's going to be really hard to do since it's underneath, 150 miles of ice. But, it's not too early to start thinking about the next mission to Pluto. Even though it takes a long time to get there, one thing we learned is that it was definitely worth it to go, and that Pluto has so many mysteries that are yet to be solved that were revealed by this mission.
Amy, what would you like to learn?
Well, I'm really interested in how Pluto formed. I'm interested in its very earliest history, and, how Charon formed. What did that impact look like? How did Pluto, evolve immediately following the impact? How did Charon evolve after the impact? And I'm also interested in what that can tell us about how the other Kuiper Belt objects may have formed.
And so we're not quite. Should we hit the inner moons like Europa and Enceladus before we hit Pluto, because they both have oceans also?
Well, maybe you can hit them on the way. Yeah.
Well, we already are planning on going back to Europa, and the European Space Agency is planning a mission to Ganymede, so I think we're going to get really good data for those. I would love to have a return to Enceladus, but I agree with Noah, a return mission to Pluto would be really phenomenal as well.
But there's nothing in the works at the moment. You have to have a lot of money for that, right?
Pluto's far away.
Yeah, and but you have spacecraft that travel pretty fast now, don't you?
Yeah.
Yeah. Hopefully, with the development of the Space Launch System, you should be able to get to the outer solar system a lot faster. So that's something we're really excited about.
All right. Well, we'll be following the excitement along with you. Noah Hammond, graduate student at the Department of Earth, Environmental, and Planetary Sciences at Brown University. Dr. Amy Bar-Millar is a senior scientist at the Planetary Science Institute. Thank you both for Moliner. I'm sorry, I mispronounced your name. Dr.
Okay.
Moliner, I'm sure, like I am, everybody mispronounces your name.
No, it's all right.
Thank you. Have a great weekend. Thanks for joining us.
Thanks
Bye-bye.
so much,
Thank you.
Ira.
After the break, a different story from another dwarf planet. What has NASA's Dawn mission found out about Ceres? Yeah, they're all out there, those dwarf planets. Maybe we'll get to a few of them. Stay with us. We'll be right back after this break. You're listening to Science Friday. I'm Ira Flato. We're talking about the planets, dwarf planets in our solar system. We were talking about Pluto, and so we're going to go from the smallest planet in our solar system now to the largest.
It's a monster. It's unforgiving. It's relentless.
No, that is not a clip from Shark Week special. They're talking about Jupiter, the giant planet that had all the ingredients to be a star. If only it had been a little bigger. Well, what you just heard is a sample of NASA's trailer for the Juno mission. That's the orbiter that will soon begin to explore Jupiter, our closest look yet. The Juno mission asks, where in the solar system did Jupiter actually form? Why is the great red spot shrinking? Does this gaseous giant have a solid core? But first, the Juno craft has to successfully insert into Jupiter's orbit, braving fast-moving debris, powerful radiation in the process. And that event is slated for a late Monday night, Independence Day. Forget the movie. This is Juno, Independence Day. And here to tell us more about Juno and what we may learn is my guest, Michelle Thaller. She's an astrophysicist and Deputy Director of Science Communication for NASA. Welcome to Science Friday.
Hey, it's great to be here, Iro. Thank you very much.
Juno was your idea of a 4th of July party at NASA, right?
No kidding, yes. And that actually was a complete coincidence. We didn't mean for it to get there on that day, but it's a wonderful time to celebrate for all of us, so I'm not complaining.
No one is. We've been looking at Jupiter for a long time, since Galileo and on. What can Juno tell us about Jupiter that the spacecraft Galileo and Cassini and all those others did not?
Wow, there's so many things. The really dramatic thing about this mission is how close we're getting. We're in this amazing orbit that takes us just almost kind of skimming over the cloud tops of Jupiter at an altitude of about 3,000 miles. And that puts us well within the very intense, very dangerous radiation belts of Jupiter. So we've never really gotten so close to the planet. Now, as you said, the Galileo spacecraft did actually drop a probe into the atmosphere of Jupiter, but it was only able to really get an up-close sample of Jupiter in that one location. And it turns out that we might have had a bit of bad luck. We might have actually landed in a kind of anomalous place in Jupiter. There are fundamental questions like what is the core like? What is the magnetic field like? What are the clouds made of? That we can really only answer very up close and personal.
Interesting, because I thought we knew so much. You see pictures of Jupiter, graphics all the time, and they peel it back, they show you the inside, whatever, but those are just graphics, is what you're saying.
Well, that's right. We actually don't know the size of Jupiter's core, the density of the core. One of the big questions is there some large rocky body underneath all of that, thousands and thousands of miles of gas and also liquid hydrogen? And in this case, we're going to be getting so close to Jupiter that the gravity, the way the spacecraft responds to the gravity of Jupiter alone should tell us what the core is like. So that's never been done before. And the radiation belts are so intense that they block out a lot of the very detailed measurements you could make of the content of oxygen, of water, of methane. A lot of this information just doesn't get through those intense radiation belts.
That was a cool sound, was it not? Can you tell us what that was, or should I fill in? Why don't you do it?
Oh, sure. That was actually from an instrument called waves on board the Juno spacecraft. And what you were listening to there was the radio waves that we recorded when we basically hit the sonic boom. We hit the shock wave that Jupiter makes with respect to the solar wind. The sun has this wonderful, very diffuse wind of high-energy particles. It travels at about 1 million miles an hour. And Jupiter's magnetic field is so strong that these wind particles sort of shock around it, actually sort of create a bow shock that we call it. And so that was the sound that Juno made on June 24th as it actually passed into the magnetic realm of Jupiter.
So this is pretty harsh environment that it's going to be passing through.
Oh, it's incredible. So, there's never been a spacecraft that's had to withstand this much radiation. On here on Earth, going around, the unit of radiation intensity is called a rad. And here on Earth, we experience about 1/3 of a rad. That's about the radiation level you and I are at right now. Over the course of its lifetime, Juno is going to experience tens of millions of rads. Wow. So, we had to make this thing really, really solid and built to last.
Does it have the protection on it, armor, things like that to protect it from this?
Oh, absolutely. So all of the instruments, and this is a new idea. This is the first time we're trying it this way. All of the science instruments on Juno are actually in a vault. They're in this 400-pound titanium box. And it's in there to survive the radiation of Jupiter. Now, the Juno spacecraft is only going to be orbiting Jupiter a little bit more than 2 years. We think eventually the radiation will just fry us. We know that's going to happen. But we have some cameras and very sensitive instrumentation in there that should survive the whole mission lifetime in that vault.
Wow. And so Jupiter then will have the kind of death of other spacecraft that have entered into its realm and go plunging into the planet?
Yes, we call that the Viking Funeral. Yeah, absolutely. So after its science mission, in February 2018 is the planned date that we will deliberately plunge Juno down into Jupiter where it will burn up. And that was the same fate that the Galileo spacecraft suffered. That was back in 2003. And in the case of Galileo, that one of the reasons we did that was to make sure that the spacecraft never landed in the pristine environments of places like Europa, the moon of Jupiter, which has a liquid water ocean under the ice.
Because you don't want to contaminate it?
Exactly. Yeah, we need to be very careful about that.
But you will be collecting data as it goes down through?
Oh, absolutely. Yes. Yeah, there's actually a number of wonderful sort of Viking burials coming up. We have the Cassini spacecraft as well that will be doing a planned entry into the planet Saturn. And both Juno and Cassini, of course, we want to know as much as we can all the way down.
Wow, because that Cassini, it's been, what a workhorse has it been.
It's been amazing. And, the images are so beautiful that I always have to sort of stop people and say, this is not a special effect. This is not computer generated. We've had this amazing spacecraft around Saturn for more than 10 years. And
so when will we start seeing pictures and data coming back from Juno?
So that's the thing that we've been trying to make sure everybody understands. The orbit insertion, which happens July 4th, is a risky, really sort of high tension maneuver, and the cameras and the science instruments have all been shut off into a protective mode. So we're not going to get images back immediately. We hope to have some images that the camera took, which is called JunoCam, as it approached Jupiter. We have one image that we've already released. We hope to have maybe a movie of the moons of Jupiter going around. But then the real action starts later in the summer. In late August, we will begin to release some images of the poles of Jupiter, and this will be the first time we've had a clear view of the north and south poles and the giant auroras of Jupiter. And then come November, we're going to go into main science operations, and we're actually going to ask the public to help us decide where we should aim the camera.
Oh, come on.
Absolutely.
Are we voting? How do we vote? I mean, are you going to give us a choice of where to go? Oh, how does that work?
On NASA's website, there will be several different locations that we think there's really interesting stuff to look at, and we are going to have the public vote on what they would most like to see. So absolutely, you have a chance to help us choose where to aim this wonderful camera that will be taking the highest resolution images of Jupiter ever taken.
Wow. I'm waiting for that. I'm going to go to the website. Now, I understand that Juno's been doing some new things for a NASA mission, certainly. You have movie-like trailers out. Trent Reznor of Nine Inch Nails made a soundtrack, right?
Yes.
People, and as you say, people can vote where to point the camera. There are also Lego figurines on board.
There are.
What is that?
Yes, 3 Lego figurines. There's a Lego figurine of Jupiter, of course, the god Jupiter, the namesake of the planet, and also Jupiter's wife, Juno. Juno is named for Jupiter's wife. The other moons of Jupiter tend to be named after Jupiter's lovers, so we're sending his wife out to keep an eye on him. And then the other Lego minifigure is Galileo. And there's a wonderful quote, an excerpt from Galileo's first observations of the moons of Jupiter, all along for the ride. The little figures are actually in spacecraft-grade aluminum, and there's a wonderful collaboration with the Lego company to bring Lego minifigures out to Jupiter.
Do you have a camera on them so we can see them while they're out there on Juno?
Well, you won't be able to see them when they're on Juno. We certainly have pictures of them that you can look at online. So if you just Google Juno Lego minifigs, you can see them there.
I've been following NASA missions for a long, long time, but I don't remember trying to get the public this involved in so many different ways on a mission to a planet before. What's the idea? You're trying to create, make the public realize how exciting this is?
Well, absolutely. I mean, I really have always been inspired by how much the public likes NASA, and I'm so lucky that I get to go out and give talks about this stuff and kind of get that from people. But this really is, all of us on the planet are in this together. And science is not something that is an isolated group of people that are doing off in some ivory tower. I think that as especially as younger scientists, I'm always on social media. I'm always connected with all my friends. It feels odd to me that there would be a large segment of the population that wouldn't be participating in this, be with us. And so that's why we're doing that.
That sounds great. I want to thank you, Michelle, for taking time to be with us today.
Oh, it was wonderful, Ira. Thank you so much.
You're welcome. Michelle Thaller, astrophysicist and NASA Deputy Director of Science Communication. She's the Juno Mission spokesperson out there in the JPL in Pasadena, California. I want to bring on another. There's so much going on in the solar system now, so much exploration. Let's turn to another close dwarf planet close to Pluto. Ceres. Ceres is the giant of the asteroid belt. And last year, NASA's Dawn spacecraft arrived at Ceres to get our first close look. And now research published in Nature suggests that liquid water, again, more water we have out there, has played a role in the planet's geology, perhaps very recently. Here to explain these findings and other news from Dawn is my next guest, Carol Raymond, Deputy Principal Investigator of the NASA Dawn mission to Ceres and co-author of 2 research papers concerning Ceres. Welcome to Science Friday.
Thank you. I'm delighted to be here.
I had to do everything I could not to play the Four Seasons music when you came on, but I'm sure you've played that yourself a few times. Do you understand what I'm talking about?
Not exactly.
You're not old enough to remember Dawn, a song that they...
Oh, yes, of course.
Of course. Okay, I've got that trivia out of the way. Tell us about this mission. What makes this so special? What are you trying to accomplish there?
Well, Ceres is actually more than an asteroid. It's really designated a dwarf planet, but it is a protoplanetary remnant left over from the very first epoch of solar system formation. So when the small planetesimals were accreting and they were merging to form protoplanets, and then those protoplanets were going on to form the planets that we know today, there were many, many objects in the solar system that were probably similar to Ceres. But Ceres is the only object that we know of in the inner solar system, which is a large, primitive protoplanet. And so by going to Ceres and studying it, we're able to look back in time and better understand what processes were going on during the time of the planet formation.
What makes you say it's primitive? How do you distinguish primitive from a more mature one?
So primitive is a relative word, of course. The far reaches of the outer solar system contain the most primitive material from our solar nebula. But in the inner solar system, we use that term to describe a body which is rich in volatiles. And of course, volatiles are just light elements. And the most familiar one to us is water, and the most important one perhaps. So we're looking for water-rich, carbon-rich, and organic-rich bodies, which are retaining a lot of that initial material that was around when the planetesimals were forming. And Ceres is that type of object, and we knew that before the Dawn spacecraft went out to visit it, because we knew how big it was, and we knew how massive it was because of how it perturbs other bodies around it, other asteroids. And so we knew that its density indicated it wasn't made of solid rock. It was made either of a very porous rock or a mixture of rock and lighter elements like ice.
Gotcha. I'm Ira Plato. This is Science Friday from PRI, Public Radio International. And so, this is a unique, then, object that we've never studied this kind before.
That's right.
And what's the best picture we can paint so far of what Ceres looks like? We've talked a lot about Pluto. If I were to look at it or be there, what would the terrain be like?
Well, what you see is mainly a very dusty surface. It's covered with what we call a lag deposit, and the lag is what's left over after volatile sublimate. So this is like what's left over when the snowbank melts on the street of Washington D.C. And so this is a kind of a dark and dusty material. But in addition to that kind of background, we're seeing the most fantastic formations of bright material dotting the surface, mostly associated with impact craters, but also curiously occurring along fracture patterns in the surface. So we've got a surface which has many very interesting geological features. I mentioned the fractures. There are large troughs on the surface, and then there are many smaller fractures in sort of chaotic radial patterns, as well as concentric ones, which follow the circular outlines of the impact craters. So those are the main elements of what makes up the surface, and then of the sort of geology of the surface. And then we have also a two major highlands and then two major lowlands. So there is some relief on Ceres, and we're still puzzling out what that might be telling us.
When you look at them, we haven't gotten close-ups, so now we get closer to them. They don't just look like little rocks out there. They look like real places.
This is a geological world. It is a small planet, and what we're understanding now, based in part on the research that was published yesterday, is that this appears to be a geologically active world. The deposits of very bright material that we were able to see as soon as we got in the vicinity of Ceres, these were the blinding bright spots that captured everybody's attention. Turns out that these are bright areas in the floor of a young crater, about 80 million years old, called Okater. And if you look in detail at that bright material, it's a very curious domed structure that's in a pit in the middle of the crater.
Wow.
And it has a radial fracture pattern on top of it. And so just looking at it, it is giving you the impression that material's coming up from below and pushing the surface up.
Dr. Raymond, I got to go. This is quite exciting. Carol Raymond, Deputy Principal Investigator of NASA's Dawn mission. Have a great weekend.
Thank you.